Hello everyone. So today there was a 2023 TDA paper. So I'm just going to discuss in brief how was the paper. So we have section A. In that we had question 1. We have to find out the circumference of a circle. So it was a geometry sum, which was, I guess it was quite simple. So one sum of geometry came of 8 marks. We have to find circumference of a circle of radius 32 geometrically and measure the normal length of the circumference. So we have to find out the circumference of the circle and we have to mention that so and so is the circumference. Then we had question B where we have to where we have to draw ellipse by arcs of circle method. So it's an engineering curve sum, right? It is for 8 marks. Arcs of circle method. So you have to draw major axis 135, minor axis is 80, and you have to draw, like this. I'm just drawing it in rough. So those who have done, they can cross check 1, 2, 3. 3 times you have to do and you have to join. So this kind of sum. Then if you see sum number 2, then sum number 2 was template. So it was interesting. They had circle, then some arc, then arc like this. Here also an arc, straight line, and arc like this, right? So in this was external. R36 was external, you can say, but it was touching this point and this point, right? So from here 36, from here 36, and from there you can draw 36. 60, which is touching at this point. So from here you cut 60, and from here you draw parallel line. So then you can draw this arc. This 25, so from here you cut 25, and from this point you cut 15 plus 25. This is 25 and 15. So from that, so wherever it will cut, from there you can draw this 15. Same way, from here you cut 15, and from here you cut 15 plus 15, 30, that way. So it was a nice sum. Over here they have mentioned insert all dimensions, so you have to give all dimensions. So, and question number 3, we'll see. Question number 3 was scales. It's a plane scale sum. On a map, a line 2 centimeter long was marked as 5 meter. So drawing length is how much? 2 centimeter. Actual length is how much? 5 meter. So how much is RF? RF is drawing length upon actual length. So that is 2 centimeter upon 500 centimeter. So that is 1 upon 250 is RF. Now calculate the RF and construct a plane scale having the same RF long enough to measure up to 27 meters. They have mentioned 27 meters. So maximum length is 27 meters. So we'll take 30 meters, right? We'll do the length of scale is equal to RF into ML. RF is 1 upon 250. Maximum length is 30 meter into 100. If you do this, 2 za, 5 5 za, 12 centimeter. You'll get 12 centimeter as length of scale. And then you divide into how many parts? 3 parts. 0, 10, 20. Here also you write meter. Here also you write meter. And here RF. So this way it will come. And then what we need to do, we have to take the measurement from the scale and draw a circle of radius 13. 13, that means you divide this also into 10 parts. You take 13 and draw circle. And in that circle, you draw triangle. And you have to inscribe a equilateral triangle. So you divide this circle into 6 parts. Then you can draw triangle. So it was like this. So I hope you people have got this, those who have done this. Then we had solids. Question number 4 was solids. They said draw front view, top view, and left hand side view of a right square prism whose axis is inclined at 45 to HP and parallel to VP. And one side of the base is inclined at 30 degree to VP. Use first angle. Now see, base inclined at 30 degree. So first we will draw base inclination. So first we will draw square like this. This will be down, this will be dotted. Now they said axis inclined at 45. So base will be inclined at 45. You will draw like this. Then you get top view here and you draw 45 degree and you draw side view here. So this is how it will come. Then we have oblique. Okay. Oblique also, what I can see, they have given front view and right hand side view. So it is somewhat like this. It goes this way. Right? And I'm just drawing it in rough just to get an idea. It's somewhat like this. And it goes inside. This also goes inside. This goes inside, but only for 15, and then this way kind of a thing. And here you have, okay. I need to check this line. I'm not too sure. This can be debatable. I'm not too sure about it because what they've given in side view is like this. So I need to think over it and then I'll come up with the answer. So I'm not too sure whether they really mean this or something else. So is there a dark line or there is no dark line? This I need to check. So whatever is given in the question paper is right or wrong. This I want to check. So I will check and I'll get back to you. Since I've just got the paper, I haven't done anything fair, but I will draw it and I'll upload it. So those who have done oblique, just make sure. And then isometric, question number 6 was ISO. So that's also a good sum. There is a circle, then you have to draw hexagon outside and then you have to draw hexagon inside. It is somewhat like this. Mine is rough, so don't, yeah. We have one sum on our video, on our YouTube channel. So it is somewhat like that. And yeah, it will come something like this. I'm just drawing it right, light. So those who have done it, they will know about that, how much is right and wrong, right? It will be something like this. This is question 6. Then we have question 7. Question 7 was also quite simple. Circle. We have front view, top view. And we have to draw development and TSS. So we know we have to draw front view, sectional top view, development. Development, all of you know, pi d. And it is cut from here. So this portion will get hatched. TSS, you can draw it here. It will come like this. And when you draw development, it will come like this. Something like this. Got it? And now 8th sum was very surprisingly interesting because in this, I feel they should have asked you to draw side view, but they have asked you only 2 things using first angle method. See, remember what they've given in third angle, front view, top view. And they've asked you to do it in first angle. So you have to draw front view up. So that means you have to draw this part up. One second, I'll just. You have to draw front view up and top view down. So I guess if you have done this, fair enough. If you haven't done it, don't worry, you won't lose much. If you haven't changed the position, you won't lose much. And this will be hatched. This line will go away. This in between line will go away, and this will be hatched like this. So first time I've seen such kind of sums, sectional front view and top view. In the sense, they didn't ask side view. They just asked only front view, top view. Okay. So this is sectional front view. This is sectional top view. This is sum number 8. So I hope you people have done well. It was not that difficult paper. And please write in the comment box, how was your paper? Thank you.